Hello everyone, it's October 30th. I don't know what happened. I mean, man, I don't know what happened. It's 3 days in a row, right? I think it is 3 days in a row. One, which, I mean, we solved, but there's a better solution. Two, we also solved. This is actually not that hard, but it still took an hour and a half yesterday. And this is today. Oh, this is an old problem. I remember this, robots and stuff. And I remember it's not hard. I think it's not hard. All right, there are some robots. I just watched a robot video from Boston Dynamics. They have, what's the name of their new robot? Oh shoot, I forgot. They used to call the old version was Atlas, and that one got deprecated, and they got a new one. New ones. Damn, what was the name of the new robot? Boston Dynamics new robot. What's it called? This one. Oh, it's still called Atlas. My bad. I thought they changed the name. But yeah, I think it's still called Atlas. And then they showed a video of the robot automatically doing tasks, moving an engine cover from one location to the other, completely self-guided. Just give a command and then it handles all the tasks by itself, which was quite impressive. All right, so now we have robots, Android robots. On the x-axis, you are given an integer array robot, where robot I is the position of the ith robot. You're also given a 2D integer array factory, where factory j is position, and limit indicates that position j is the position of the jth factory, and the jth factory can repair at most limit j robot.
I feel much warmer down here.
Oh, all right, just warm yourself up. Well, get the AC or space heater in no time.
Tomorrow.
Tomorrow.
It was torture.
Ah, terrible, terrible. The positions of each robot are unique. The positions of each factory are also unique. Wait, do they overlap? I don't remember. Note that the robot can be in the same position as the factory initially. Okay, yeah, that's... All the robots are initially broken. They keep moving in one direction. Oh, by the way, I just watched a video. The Chinese weightlifter, they have to pass some strength test, and one of them is this.
The climbing?
The climbing. I mean, I'm recording, so I'll show you some other day.
The climbing machine?
The climbing machine.
Reverse?
Yeah.
See, that thing's hard.
I guess I think it is hard. And the funny thing is, so usually in all other countries that I know of, if you want to qualify for a national competition, you have to reach, your total have to reach a certain level. And they don't care how you reach it. Just at some competition, sanctioned competition, you reach that level and then you're in. But the Chinese one is very different. Chinese one is you have to pass some strength tests. They don't test your clean and jerk or snatch. No, they test your strength.
Like kids?
No, just like adults to participate in the competition. And they have like a lifting strength, static strength, all type of strength. And one of them is this. They have to do this. They have to do.
Put that on G-Fit game.
The abs we do, where we just like hook our legs on the bar and then we go back down, and they have to like do that on the edge of a seat, and somebody will hold their leg and then just hold this position. You can see a bunch of those guys just hold this position.
Okay, whoever holds the longest? Or...
I guess they have a time limit you have to hold to show that your core strength pass. So like you have to pass every single one. Some of them is like squat. Back squat you have to reach If you're this weight category, you have to reach this amount of back squat, front squat, deadlift, snatch grade deadlift. Now, if you cannot click the check the mark, you cannot compete. And then they have to do those arrow, like that climbing thing. They have to do the abs. They have to do vertical jumps. It was absolutely ridiculous. But on the other hand, I don't know, maybe it is a good way to ensure that people are competing on the same level. But yeah, it's just funny to see all those Olympic level athletes doing the climbing thing. Yeah, it's
They were good at it.
uh-huh.
You call them poop. They were good at it.
No, man, they never train for it. They just need to test. This is actually a good thing to suggest for GFit. Because apparently there are some leaked videos. I can just post all these leaked videos on the barbell channel and then say we should do this. Vertical jump is actually quite an interesting thing to test. That'd be very fun. Broad jump. I know the broad jump is a very important part of selection of kids. 5, 6-year-old. How do you know they're athletic? You put them in broad jump. Simple, easy. One event, and you can tell immediately which one has potential, which one doesn't. All right, let's go back to the problem. We have 3 hard ones in a row. And surprisingly, I got the first 2 hard ones by myself.
I'm not surprised.
But after a lot of effort. Okay, today this is I've done this before. Not sure if I read the solution. All right, anyway, where are we? Okay, robot can be in the same position as factory initially. All the robots are initially broken. They keep moving in one direction. The direction could be the negative or the positive, okay? When a robot reaches a factor that did not reach its limit, the factor repairs the robot and it stops moving. At any moment, you can set the initial direction of moving for some robot. Your target is to minimize the total distance traveled by all the robots. Return the minimum total distance traveled by all the robots. All robots can be. All robots move at the same speed. If 2 robots move in the same direction, they never collide. If 2 robots move in opposite direction and they meet at some point, they do not collide, they just cross each other. If a robot passes by a factor that reaches the limit, it crosses as if it does not exist. If a robot moves from position X to Y, the distance is the absolute difference between the 2. Okay, we need to we can decide how they move, right? We can decide how they move. We just want to know what is the minimum amount of distance that need to be traveled. At any moment, you can set the initial direction of moving for some robot. Target is to minimize the total distance traveled. Yeah, so basically they're just going to keep travel, and if they hit a factory that does not reach the limit, and then they will stop. And if they reach one that does reach the limit, they'll keep going. Oh man, how do we solve this? I don't remember at all. All right, first one, we have some already sitting on top of factory, so that one doesn't move. And these 2, this move here, so we move at 4. And we move this way. And of course, we can move the other direction, right? But if we move the other direction, that is going to cost more. Oh. What do you think? So I have factories, okay? So I have factories, okay, I would say 0, 1, 1, 2, 3, 4, 5, 6. Right, I have factories at 2. So basically this I have 2 capacities, and this I have 2 capacities, right? And then I have robots anywhere, okay? And we need to know how to make them move so that, okay, so here's the thing. If I have a robot to the left of the leftmost factory, then there's only one way for it to go. It has to go this direction. Same for the robot here. If there's a robot on top of a factory, which, and it does say that let's see, the limit is smaller equal to robot dot length, but the limit could be 0, right? Limit could be 0, so it's not guaranteed that whoever is on top. But if we have a robot on top of a factory and the factory has capacity, then it is a better strategy just to no move. Because if you move, I'm actually not sure about that. If you move, then that one will definitely incur. And right, if you move, then that one will incur. And you say if that one moves, so somebody else can come. Like maybe something that's also very close by, and they can come. And it will be the same. It will be the same. It will be the same. So the strategy is not to move, right? If you move, then the worst case you will get more distance, right? And the best case you will have the same amount of distance. So if we have capacity and it's overlapping, so you just don't move. And anything on the outside has to move in. There's no way. Okay. So now what we did is kind of initial analysis. And then, I mean, for each robot, ideally, if you have a robot in between 2 factories, you want to go to these 2 factories unless they are, not available. If we have factory at 0, basically just ignore it, right? Then, and ideally, the ones to the left, you want to just to hit this one because you don't want to keep going. And if this one has capacity, then the ones to the left will go to this one. And the ones in the middle, okay? The ones in the middle, how do we all right, we probably need some ingenuity in DP. Because we have 2 arrays, okay? We have an array of a robot, and we have an array of factories. So, and the size is 100, so we are actually able to run O(n) squared, O(n) tripled, right? O(n) to the 3rd. But the 2 are not the same, right? The length is not the same. So we can say maybe we want, what do we want? We want the minimum total distance traveled, okay? Minimum total distance traveled. So if I say dpi, right? So we kind of have 2 states. One is the robots. We can say dpi, I is the robot. And then dpij, can we do a dpij on this one? A dp, ij. Can we say I is a robot and j is the factory? What do you mean by factory? Because I have a robot, and then I say when I go to this robot, how do you get a state on the factory? You can say, oof. Okay, hold on. I want to prove some stuff. If I have two opening here, and I have a robot, it is the best strategy for the robot to enter on one of these two, instead of going to something further, right? Because if it goes to something further, and you think it can make it shorter, okay? Doesn't matter, so I want to skip this, so that it can go here, and in some other way you say that will be shorter, then I can counter argue that, because if the other one is on the same side, right? If the other one is on the same side, then doing this and this. Okay, I'll be back. Alright, let's continue. Yeah, we just want to prove that if I can go from here to here, then it is a worse scenario. Go from this, I want to go to another one, I can skip this, right? I think it will be worse because if I say I go here and another one go here, I say this is shorter, then I can argue that if I go this one to here, because we have to travel this plus this and travel this, right? And if we swap them, it's exactly the same. So we and if we have something from here need to travel here, then we actually travel more. So my argument is it's always the best to make you go to the one nearest to you, unless it's not possible. So if that's the case, then for each robot I check the two sides and decide which side to go. And I can start with this one. This is the only one. It can only go to here. So when this one go here, right? And I have a new capacity here, and I have, yeah, I do this, and then this one becomes the leftmost, right? And now for this one leftmost, I have two options. I can either go here, or I can go here. Now if we go truly greedy, I'll go here, but then you're reducing the opportunity. So yeah, that's the thing. You don't know, right? You don't know. Which side to go. No idea. I need some hints. Okay, DP. Oh, sorting. Sort by position. Okay, now what? After sorting, notice that each factory should repair some subset of robots. It's like, duh. Find the minimum total distance, repair first iRobots. Oh, here. This is the DP. dpij equals the minimum distance to fix robots all the way to I with factories all the way to J. That's the hint. Okay, so that's what dpij means. Okay. dpij means the minimum distance to fix the first I robots with the first J factories. Okay, so dp00 is, it's not the first, up to So in this case, I have robots is 0, 4, 6. It's already sorted. And I'll have factories is 2, 2, and 6, 2. Right? So 0, 0 is fixing the 0th robot with 0th factories. And the distance is going to be 2. Right? Distance is going to be 2. But how do we keep track of the number of remaining capacity? Or even if you know dpij, right? Then how do you know dp, or how do we do dpij? We have the ith robot, right? Okay, ith robot with the first j. So it's just as a, yeah, first j factories, right? Okay. Then usually you will say, what about dpi minus 1 j? And what about dpi and then j minus 1, right? So dpi minus 1 j is the first I minus 1 robots with the j factories. Okay, that's the minimum. And then if you want to do one more, then you go through the first j factories and try to find one that has capacity and also the smallest distance. So you go through them, right? And you find one with the smallest capacity. Oh, find one with the capacity and the smallest, and that's one idea. Yeah, that's how you get from I minus 1 j. And from here, dpi and j minus 1, right? dpi minus j minus 1 is you are the ith, but you use j minus 1 factorial. If it's not possible, then we can just say it's just infinite, right? So you do j minus 1. And if it's possible, and you compare to this, right? Because you say you have I robot for j minus 1, the minimum. Okay. J minus 1 minimum. And now you say I want to do I robot with j minimum. Do we even check this? Do we even check this? Oh, we just check I minus 1 j. Because I minus 1 j can be using anything. And then for the j ith robot coming in, or I robot with this, then we basically give one more, right? We give one more a factory, right? We give one more factory. Or we can look at I minus 1 j minus 1. Alright, now is I and j. But you still haven't figured out how do we keep track of the state. capacity? I don't know. Let me think again. We have robot at 046, okay? We have factory at 22 and at 62. And we say DP00, okay? Zeroth robot fixed at zeroth factory. And the amount of distance moved need to be 2. And usually we'll say, what if we do DP01? Zeroth robot, try to fix these two, anyone. So we basically just, check. If we fix here, requires 2, fix here requires 6, this is also 2, right? That's it, that's 0, okay. Now we say DP1, 0, okay. DP1, 0, it's this, using this, right? DP1, 0. How do we do that? We have to use the 0, 0, okay? So 0, 0, and this still have capacity. So we check, so this will give you 4, right? Because you check 0, 0, which has a value, which means this one has, we still haven't solved this problem. But anyway, so this has 1 capacity loss, and we have still 1 capacity, and this one coming here. So now we get 4, right? Because this one coming here. And we can also do DP11, which is 1, 1. What is the smallest, right? So I can do, let's say, if I look at DP01, right? 0 getting 2, I got 2. And I got capacity here. But when this one comes, I don't know that the capacity was here. So we need a capacity. We need a capacity, but that goes with the state. Because each state has a different capacity. And this one needs to go. Either one. I check this is 2, this is 2, so it doesn't matter. So this is going to be 4. Alright? But it doesn't matter, I can go here or I can go here. But with which side I go, what effect? It may affect. Right? It may affect. So what if we say, what's DP1? 0. So 1, 0 out of that is 4. So I already handled it. So I think I just need to make sure it's the smallest. I don't know. Oh, and then check solution. Lord. That was so simple. To see this problem as a knapsack, each factory is a knapsack because it has a capacity. The question can be converted to finding the optimal way to fill all the factories with the given robots. The target optimization is the absolute distance between each robot and its factory, but the general idea is the same. For each robot, we either let it be fixed by the current factory, or we skip to the next factory. DJK is the minimum total distance to fix robot I to the end with factory J. Oh, J already have fixed K robots. Okay, so J already fixed J robots. That's an important insight. So when we say dpij, I can say ith robot. We're facing the jth. Okay, so ith robot we try to fix in the jth up to j, right? In the jth, which has capacity left with k capacity left. Okay, and then we say I can fix it there. That we produce a value, right? I'll fix it there. Then we will produce a value. How do we produce a value? Then you will produce a value by the previous I minus 1j and then k, right? You produce a value there plus whatever you have now, okay? So that's you fixed there. Or you can choose not to fix at the jth, right? Not to fix at the jth. So if you don't fix at the jth, and we say you just fix at j plus 1. Remember, it doesn't matter because we go through every single j, right? If you don't fix this, you'll fix the next one. So you go fix at the next one. Really, that's it? You fix on the next one. All right, I can't wrap my head around. Let me think of the other way and how this one is done. IJK is to fix robots I to the end, or fix I to the end with factory J having already fixed K robots. Hold on. With factory J already fixing K robots. What is the minimum? Now with option 1, robot I skip factory J. Thus the total distance is I factory I skips factory J. Robots I skip factory J. Up until, so from I to the end, right? From I to the end, I say we're trying to fix on this factory J, but I don't know. I choose not to fix on factory J. Now I try to go on the next one. and it's gonna be k is already fixed. Okay, k is already fixed. So we go to the next one. I already fixed as 0, so it's gonna be that is option 1. I don't fix on this one. I'll go for the next one. And option 2 is I will fix on this one, right? Is fixed to factory j if it has capacity, right? Then it's gonna be the distance. You find the distance, right? I to the n. So you fix I in j with capacity. So you get that fixed, and it's gonna be I plus 1. So that plus I plus 1, j plus 1, 0. Oh, I plus 1, j, 0. I plus 1, j. The option 2, k plus 1. Oh, yes, k plus 1, because, yes, k plus 1. Yeah, these are the two scenarios. We picked the smaller of the two. Okay, I understand that. Edge case, if I is equal to robot, which means we have finished all robots, then that's the end. That one will return 0, right? Yes, we have fit all, and we should return 0. If j is equal to, but I has not, that's maximum. But have used up all the factories. If k is larger than factory, then we have used up all, we shall return math, yeah. Okay, I have the important, what's that? The condition for k smaller than factory shall be checked before calling. Because if we don't check it, it will be very complicated to check for the edge case. In the edge case, when we check for I, we must also check for k. If I reaches the end, k is good, we are good. But if I reaches the end, k is not good, then we are bad. Plus when we check k, we need j, so check for j as well. Yet if we check for j, we need to make sure we also check for I, because it is allowed for both I and j to reach the end, but not just one of them. I have no idea, but it looks like it makes sense. Looks like it makes sense. Okay, so that was IJK, right? Damn it. Okay, so we have to give ourselves some challenge. We can't just copy and paste the previous answer. So we get an idea. Then previously what I did was top down. Very simple. We skip J, or we keep going on. We use J, and that's it. How can we do it bottom up? Okay, how can we do it bottom up? Well, bottom up, we have to think differently. I think just on the I level. So here, in this top down, we say we're trying to find current I, the ith robot. Which one do we go, right? Which one do we go? And if we do bottom up, then we say for we already filled the previous, right? Yes. So again, so there will be like this, right? dp ijk is the minimum distance, right, of fixing robots all the way to I plus 1, right? Fixing robot basically fix the robot I using J using factory j with not capacity, with k already fixed, right? Something like that. Now I have all of this. Now we want to do dpi plus 1, right? How do you do dpi plus 1? Well, dpi plus 1, or actually that's not a good way to think. The good way to think is just say, if I wanted the dpi jk, right? So I'm looking at robot I. All the previous robots has been fixed, okay? I'm looking at robot I. And for robot I want to fix with j. And I have two options. Either I use j, right? Or I don't use j. If I don't use j, like I skip j, wow, it's hard for me to reason this. Especially knapsack. I don't think I have ever done a bottom up on knapsack. It's always top down. The top down is easier. I can just visualize. Right, if I don't do this, I'll skip to the next one. That's kind of the thinking process. I'll do the next one. But this is different. This is because the ones you've done are like smaller K's, because bigger K you haven't done yet. Yeah, this one just called 0, 0, 0, right? Yeah, because I can choose to use it or I can choose not to use it. Here is different. Here is, we filled them already. And if I don't, how do I move forward? Nah, I give up. Let's just do top down. It's a top down problem. Let's see, solution. I think there is. I'm interested in this tabulation. Each robot can go to the current factory or skip it. Yes, for each robot factory pairing, we need the current position of the robot in a factory to calculate the distance. Yes, the minimum distance of if this robot is assigned to this factory or skipped to the next one. Okay, dpij represents the minimum distance to assign robots starting from I to factories starting from, wait, really? Starting from I to assign it starting from J. We'll fill this starting from the last robot and factory to ensure our choice of subsequent. Oh, okay, so that's slightly different. But how do you handle the capacity part? I don't know. Assign the current I to J and move to I plus 1 J. Assign, so we have IJ, right? If I go to J, then we move, because I assign this robot, so I move to the next one, so I plus 1, we'll try to do J. If we skip, we'll move to IJ plus 1. That's correct. The minimum of these two. Yes. Because this one we already computed, because we go from right to left, so dpi j plus 1 has already been computed. And if we move to J, so robot I minus factory J plus dpi plus 1 J. Yes. dp00 will hold the minimum distance needed to assign all robots. dp00 will hold. That's also correct, because we say, oh, so that's exactly the same thought process. But how about your capacity? How do you handle capacity? Okay, sort robots and sort factory. Flatten factory position according to their capacity. What? What is this? Oh, factory position. Right, this is a robot. Now your factory become 2266. And then we can say robot 0, we want to fit. We want dpij. It's the same as the other one. Is the I to the end robots, right? I to the n robots fitting j to the end factory. What's the minimum distance, right? So we're looking at ith robot and a jth factory. So I can either choose the jth factory or I can skip the jth factory. It's a knapsack, right? So if I choose the jth factory, then there's no issue with the capacity, because the capacity is oh, this flattening idea is really brilliant. Right, we choose that, we just choose it, and then we move on. Right, we choose it, we grab its distance, no, its position, right? And then we done this, so it should be I plus 1 j, right? So I use this I plus 1 j. That's not right, because I use it should be j plus 1. Yeah, because either you take it or you don't take it. If you take it, right, if you take it, then is then is I plus 1 j plus 1. I don't know. It says I plus 1 j. No, it is j plus 1. There we go. Yeah. So it's slightly different from what, because in this case we're not considering like flattening it. Like if you want to do it this way, you need another one. You need another k out there, right? You need another k in order to decide on. I mean, technically you can prepare another one, but maybe 3D. 2D wise, yeah, you do it and you move on, right? Or you skip it and then you just do the one you already have, right? So if I make it slightly bigger, right, I, plus 1, jn plus 1, and then we put that as a 0, and then for each one, right, for each one when we start, it's either you don't take it, then you go here, right? If you don't take it, then it will be ij plus 1, right? Ij plus 1, then it will be robots cannot get fixed, since it'll be infinite, right? Or you take this, right? You take this, then you move on to the next one, and it will be, that will be 0 because you already finished. So basically the last row, right? Because the last row is I. If I hit the last and j has not hit the last, these are all zeros. Or even if j hit the last, is also zeros. But if j hit the last, but I has not hit the last, those are all infinite. Okay, I think we have kind of an idea of how we want to do it. Oh, is that the last day? No, I think October has 31st day. Yep, October has 31 days. Oh, this idea of flattening is, I don't know, very, very smart. be length. And then we need a flat factory. Ooh, we don't know. Damn, this has to be... Alright, it has to be this. FO factory. Alright, so this is really smart. Flatten factory. So we don't need to use a 3D DP. Okay, and then once it's done, and then we can say collections sort flat factory. And arrays, no, and then collections sort robot. Okay, now these two are sorted, and then we can do a DP. Right, so we can say DP equal to new int m plus 1 n plus 1. No, that's actually no. Or delay it. Flat fac. And here, yeah, you don't even use the other one. This should be size, right? Okay, then we can say for, actually, we just need to set it to a max. What do you think a max will be? I know what a max is gonna be. So basically, the last column, so for int I equal to 0, I smaller equal to, no, smaller than m, right, I plus plus, dp I n so equal to integer dot max value. So all of these are used up all factories, but still have robots. Unfixed, unrepaired robots. Okay, now we're gonna go from right to left, right? For int I equal to m minus 1, I large equal to 0, I minus minus. Okay. I say for int j equal to m minus 1, j large equal to 0, j minus minus. Okay, so we have I and we have j. Okay, so now we need to find out dpij. So we can say dpij equal to, before we do that, we need to say dpij equal to minimum distance of fixing robots I to the n using factories flat fac j to the end. So this is option 1, so we just skip. So simply dp I j plus 1. Alright, this is option 1. Skip factory j. Flat fact. Flat fact j. And option 2 is we don't skip, and then dpi j the math.maximum dpi j. So if we don't skip, then math.abs robot I minus flat fact j. Right, that's don't skip. If we don't skip, then we used up, then it's going to be dpi plus 1, j plus 1. So this is option 2. Use flat fact 1j. So once we're done, we'll return dp00. Hey, this one on Nightmare. This one should be on Nightmare. 2 rounds, still not able to solve it. Yep, it's on Nightmare. Second time with this problem. Still unable to solve. The top down dp ijk solution is good, where dp ijk is the minimum distance of fixing robot j to the n using factory j to the n with factory j having k robots already fixed. This solution comes from the official solution, which flattens the factory array to make the dp effort 2D instead of 3D. The idea is the same, right? With dpij go to minimum distance of fixing robot j to the I to the n using factories, using flat fac j to the n. We need to go from right to left to ensure that each dp step, right, has previously computed value, where n is m is LAN robot, and n is the total number of total number of capacities of all factories. Okay, let's see if this one work. It should, because we basically copy and paste with our own understanding. Oh, you have like negative stuff. Oh man, negative stuff. Oh, that's fine. It don't really matter negative stuff for now. We are using indices. But your return value does not look good because I do a max as opposed to do a min. And this is interesting. Well, we just don't use max value. We set it to, you know, max distance. Oh, max distance can be long. Yeah, it's a long. Damn it. Do we have like long the max value? But it's still, we're still gonna have this issue, right? So this should be long. This should be long. So we have 100 robots, right? So can we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? We do that. Does that work? Oh, it's too long? This is 10 to the 9th. We're gonna do one more. How about we do long the max value? Yeah, and we still have out of range. Yep, that is an issue. Let me think about it. How do we solve this problem? The lazy way doesn't work. Do we have long? I'm serious. Do we have long? Do we have long? I don't think so. Yeah, no, I think we can do. Damn you, man. I mean, what we can do is this I plus 1, j plus 1, we use an if check, okay? So if I don't do this, and we also don't do this, right? And we don't do this, so we go, right? And we just check j plus 1, right? We don't have a j plus 1. We say if j plus 1, this option 1, basically if we have j plus 1, then we do it. If we don't have, it's going to be infinite, right? That's going to be, I think we just have to be very careful in the last column. I do the final one, right? So I say be basically used up, right? That's gonna be maximum, or I just use it, right? Maximum. I think this we can do, right? So we can say j is equal to n minus 1. If it's equal to, then we say long dot max value. If not, we say dp this, okay? And then we do this, and then plus, this is another thing. This depends, right? If you have, oh Lord, yeah, this gets a little bit complicated. What we say is if I is equal to n minus 1 and j is smaller than n minus 1, that's a 0. So basically this is what I'm thinking, right? Next file. Okay, so if I is equal to n minus 1, right, and j is equal to, no, if j is, no, I think it's if I is equal to m minus 1, then regardless it's going to be 0. I say if that is equal to m minus 1, that's going to be 0. If I, so the last, last row, right? And last row, and then we need to move out, and this is always going to be 0. Now, if I is not in the last row, then if j gets out, then that's going to be infinite. Right? Okay, so next eval is this. J is equal to n minus 1. Then it's going to be long down max value. Or dp I plus 1, j plus 1. Next eval. Oh. Should be long. Okay. Alright, let's try this. We still have, oh, okay. So maybe we need to do this. If but how do we know? We still have to add them together. Or we, it's hard. I don't know what would be the best way to do this. So if next eval is equal to long done max value, or so next eval option 2 val, if next eval is equal to long dot max value, then it's gonna be long dot max value as well. But if next eval is not, then I think we can no, do something like this. OPT2 val. Might as well just change this. You know, long PT1 val. Right? And we'll change this one as well. Okay. This doesn't work. There you go, this one works. So have to be very ingenious in dealing with this overflow issue. But no, I didn't solve it myself, so no, this is pretty bad. It's a tough problem. Tough mainly because I wasn't quite sure. I was thinking, I think Knapsack I kind of think of a knapsack just for a little while, just a little second, but then I give up because I was thinking knapsack. How can we do knapsack? Knapsack requires 2 to the n. Man, I didn't keep thinking about it because if you sort it and knapsack it, yeah, it will work. I think one type of knapsack you can also use DP to do it. Because this one you can sort and you have an order. Knapsack is you have all the bags and each one you have to go start from. Yeah, if there's a certain order, then you can DP it. But knapsack is you have one bag, right? You have one bag and you have a bunch of balls. And then you try to put this in each round. You're deciding, okay, either I put it or I don't put it. Right? And you put it, you have a state. You don't put it, you have another state. And then it's 2 to the n. But this is different. You don't have one bag. You have like a bunch of bags. And once you fill one bag, you can move on. And it's not to count the number of ways or the maximum you can put. Yeah, it's a tough one. But this idea of flattening, I think this is pretty genius. I think this is probably the most genius of the solution, is flattening. Oh, actually there's another solution. I think there's one called optimized. Space optimized. Basically, usually this just means we don't have to use 2D DP. And if you think about it, in this one we use j plus 1, right? And this one we use I plus 1, j plus 1, which means, and then we compute from right to left. So j plus 1, and each I can be just in a 1D array, right? And then we go from right to left. So each time when we compute, we need a j plus 1, and we need I plus 1. Like I plus 1, j plus 1 is the previous value. How do we do one way? I mean, yeah, you can always do. You can just use 2 arrays. 2 1D array. Yeah, you can do that. Can you do that? 2 1D array. I plus 1, j plus 1 is like the previous, right? And how about I j plus 1? Don't know. Don't want to know. I just leave it. Yeah, let's just leave it. And I have no intention to revisit it. Yeah, it's just one of those DP problems. Some DP problems has this issue. Python is actually very simple to deal with this because there's no overflow, so you don't have to consider that. And then, right, recursion is also simple. Sorting. Okay, sorting and I to the end can fit j to the end. This is a pattern. This is definitely a pattern that need to get more practice on. All right, that will be it. 1 hour and a half again. 3 days in a row.